In part one, when we were looking at decision theory, we considered those situations where you have possible outcomes associated with each action, and there is some known probabilities on how likely each of these outcomes might occur. Here now we're looking at two different situations. So we're still using these principles to determine what action we should take. The two situations we're considering in part two are decisions under certainty and under uncertainty. Now, decisions under certainty are fairly straightforward. There's a single known state of the world. There's a single outcome associated with each action that you are considering. And in this case, if the outcomes for each of the possible actions are known, then it's rational to take the action associated with the greatest utility. The idea here is you are maximizing utility, and that would be the rational thing to do. This at least prevents emotions from heading you towards something that is going to be a poor outcome for you. So it is using rationality, but it's fairly straightforward. A bit more interesting are those decisions under uncertainty. Here, there are two or more states of the world associated with each action. So you don't know exactly what's going to be the outcome with the action that you take, but the probabilities of the various states associated with the actions are not known. You don't know how likely any given outcome is when you take a particular action. Now, if only crude probabilities could be calculated, then it's best to go ahead and use some crude probabilities and then use the decision under risk method for deciding what to do. But with decisions under uncertainty, the potential outcomes are ranked then. What you do is you rank them according to utility. And this is going to be a subjective ranking. So it's going to depend on personal preferences and priority. So certainly it can be rational, say, to become a physician or to become an attorney or to become a nurse, right? It's rational to do these things. And some people have a more desires and fits in with their priorities in life to take one of those career paths maybe than another. So let's think about how this method works. So the first thing you do is you take that subjective ranking for each of the possible outcomes. You assign a ranking, and then how you decide what to do is going to vary according to whether you're a cautious player, a gambler, or a calculator. Now, so this fits with your particular personality. You can use decisions under uncertainty in different ways according to the way you like to approach life. Do you want to avoid bad outcomes? Is that your priority? Then you'd be a cautious player. Do you want to maximize the greatest possible good? That's going to be the gambler, right? And so a gambler, right, is the one that's going to choose the action that has the highest possible outcome, even if it also has the lowest possible outcome. Now recall, we warned against this in a sense when you were doing decisions under risk, because you don't always want to go for the greatest outcome, especially when your probabilities are known. But when probabilities aren't known, so you just have no idea which way things are going to go, you can use this method of decisions under uncertainty. Now, again, a cautious player is going to want to avoid whatever action it is that might have the lowest possible outcome of utility. So you might want to say they want to maximize the minimum, right? You want to avoid the worst case scenario. A calculator, and this is going to be the more interesting situation, and the one that I would recommend taking typically, is going to be the person who can assign values to the various potential outcomes and then choose the action with the highest average utility. Now, probability really isn't involved here because you don't know the probability of various outcomes, but you still can use this method of calculating to determine what to do. So if one is a calculator, again, she's going to average the utilities of the possible outcomes. And then once you've done that, you simply take the action that has the highest average. That's going to be the way to maximize utility. And so first, what you're going to do is rank each possible outcome. So setting up a chart can help you do this, considering maybe making a list where you have all the possible outcomes associated with your actions, and then you rank them, most preferable to least preferable. What would be the best thing to happen? What would be the least thing to happen? And then you kind of assess these outcomes maybe on the scale of 1 to 10. That is a useful way of doing this. Okay, this is very abstract now, so let's put it into practice. Let's suppose that Siddhesha is considering going to 2 different graduate programs. So she's maybe in her junior or senior year and looking at graduate programs. She wants to go on and study. And then she's considering which one to apply for. Maybe she's a senior and she's been accepted to both. All right. So what you do is you rank them first, and then you assess the possible utility on a 10-point scale. And so here's what we mean. Here's my suggestion with a table. And in graduate school, all I'm considering here is the school and a professor that you might want to work with. So in this case, Siddhesha would really like to work with a professor who is at ISU. So that's the #1 outcome. That would be the best outcome for her in going to graduate school. Now, the second best outcome would be to work with the best professor, the one that she likes the most at U of I. And so that's the second best outcome. The third best outcome, when she's not able to work with her favorite professor at the U of I, is her choice. She would rather be at the U of I not working with her favorite professor than be at ISU not working with her favorite professor. So in the first numbers on the left here are the ranks, right? We're just ranking all 4 of these possible outcomes, 1 through 4. And then in parentheses, we're assigning the utility based on our preferences and priorities, right? And so we're ranking those on a scale of 1 to 10. So that's what Siddhesha does. And here's the chart again as we talk through it. So going to ISU, what Siddhesha would do as a calculator with decisions under uncertainty is to average these utilities. So going to ISU gives an average utility of 6, right? You average 10 and 2, so you have 12 divided by 2 is 6. Going to U of I, the average utility is 7, right? 8 plus 6 is 14, divide that by 2 and you get 7. And so the overall calculator is going to say, well, the best utility average is going to the U of I, so that's the rational choice to make. Now, going back to other ways of approaching decisions under uncertainty, right? A gambler is definitely going to ISU. They're going to accept that and plan on going there with that possibility of working with the preferred professor, whereas the cautious player is going to go to U of I because they want to avoid that situation where they can't work with their preferred professor and be at ISU. So, and it could line up in different ways, right? Sometimes the calculation is going to favor the cautious player. Sometimes the calculation is going to favor what the gambler would have done. Now, before we wrap this up, I want to talk about a fallacy associated with decisions, and that is the gambler's fallacy. This is a situation where, say, you have a law of averages, and it does not imply that a string of unusual but independent events are going to be evened out soon. Okay, so suppose we could apply this in a variety of situations. Suppose your favorite baseball player has a batting average of 300, and they've got 5 hits in a row. So what's the average that they get a hit the next time they're up to bat? Well, it's 300. Now I know, for those of you who are athletes and have experienced this, sometimes you get hot, or some sports fans of any kind can see that sometimes people just seem to hone in and do especially well for a while. So that can happen. If we're talking about a situation where we're just doing something with straight probability, like the odds of obtaining a heads when you're tossing a fair coin, even if you get 5 heads in a row and you say, well, the probability of getting 6 heads in a row is exceedingly low, which it is exceedingly low. What's the probability of getting a heads on that 6th toss? It's 0.5. It's the same as always. It doesn't matter what's happened prior. If you had 5 tails in a row or 5 heads in a row, it doesn't matter what those first 5 outcomes were. The probability of getting a heads on the 6th toss is 0.5. Now, here is where people get into mistakes, right? You don't get hot when you're gambling in the same way that you do when you're playing sports, right? When you're playing sports, you have some control over the outcome. Maybe you're seeing things extra clearly that day. Maybe you just have especially a good day, and that can affect how you perform on the court or the field. When you're playing blackjack, or worse, roulette table or a slot machine, you don't say that, oh, I've won 5 times in a row, so I know I'm going to win, so I'm going to put it all in on this next one. That would not be a rational thing to do. You have to step back, recognize the odds are the same with these independent kinds of outcomes.